Okay, guys. So here we go. Um, we're doing the next one. This is based on a square root function, right? Square rooting is the main function here. Square root x, and we know that one. We did that one before. Center point 0, 0, 1 to the right, 1 up, and 4 to the right, 2 up. This is the original square root function we knew from last time. What's changing here? Moving 3 to the left, 2 up. So that means starting position. 3 to the left, 2 up is right there. New starting position. And then I have a negative 2 out front. Negative 2 means instead of opening upwards, it should be opening downwards instead. So it should be opening this way. And 2, that 2 means instead of going 1 to the right and down 1, I'm going to go 1 to the right and down 2. So this way. Yeah. And then instead of going 2 to the right and down, what was it? No, I'm sorry. Instead of going, normally I would go 1, 2, 3, 4 to the right and down 2, right? So normally I'd go like this. But this time I'm going to go down 4. So 4 to the right, down 4. 1, 2, 3, 4. That puts me right here. Right? 1, 2, 3, 4. And 1, 2, 3, 4. So now connect those dots. And there it is. Something like that. Yeah. So the blue is the end result after the transformations were applied to the red being the original. 16 done. Okay, next we got a cube root. Cube root function. Put that tick mark back. So here's original cube root function. Cube root is 1. Cube root of negative 1 is negative 1. So remember this guy? And cube root of what can you take? Cube root of 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Here's 8 here. And 1, 2, 3, 4, 5, 6, 7. Negative 8 right there. Cube root of 8 is going to be 2 because 2 to the third is 8, right? So cube root function looks something like this originally. And then like this, right? You remember this from last class? Okay, so that's the original function. This time I'm taking, easy, only shifting, easy. 3 to the right, 1 up. Otherwise the same. Let's do black. Let's do black. So 3 to the right, 1, 2, 3, new starting position right there. And 1 up right there. But otherwise the shape is the same. And what is the shape? Sorry, this is the starting position. Shape says 1 up, 1 to the right. And from there, 8 to the right, 2 up, right? So 1, 2, 3, 4, 5, 6, 7, 8 right here. And 2 up would be right there. So here's my points. And then left 1, down 1 right there, right? And then left 8, 1, 2, 3, 4, 5, 6, 7, 8. Down 2 would be right here. So something like this. Oops, I kind of missed here. Oops. Did it again. Something like that and like that. Right? Or, I could have done, because there's no translations to worry about, it's the exact same shape as the original, right? So I could have just lassoed this thing and I need to lasso. Oh, actually, no, it's not going to let me lasso the right parts because it's going to move the whole graph. Sorry. I lied. Sorry. Oh, actually, I could do to show you the translation. I could just redraw this thing one crack. Watch this. This is not necessary, but too late. I'm invested. Okay. Oh my gosh. It's terrible. Sorry, guys. It's harder than it looks to draw on this perfectly smooth surface. Okay, so that was the original, right? But then I'm just doing a shift. 3 to the right. 3 to the right. 1, 2, 3, and 1 up, like that. There it goes. No, it kind of looks like I was graphing earlier, right? Sort of, but yeah. That's the idea anyway. Okay, let's move on. So that one was number 17. Now to number 18. Okay, what's the underlying function for 18? Looks like it's 1 over x. Do you see that? It's 1 over x. Except here there's a plus thing, that's a shift, and then there's a minus here. And then there's also a 2 that's added. So I'm going to do a little algebra here first, guys. So original function will be 1 over x. And remember that guy, 1 over 1 is 1. 1 over negative 1 is negative 1. And otherwise it approaches both asymptotes here like this. Something like that. Has this general shape. Okay, I'm going to do a little algebra for our new function. F of x equals to 2 minus 1 over x plus 2. I'm going to rewrite this just super little bit algebra here. I'm going to just rewrite it as negative 1 over x plus 2 plus 2. Then it looks a little more familiar, right? This is f of x. Wait, what do I mean? What do I want to say? If I look at my original kind of translation list like this, here, this is like y is equal to f of x plus 2, and then with a negative applied to that, and then a plus 2. That's what's happening. So there's a shift by 2 to the left, 2 up, and then there's also this what do you call? Reflection. Okay, so let's do those things. First of all, let's do the translations, right? So plus 2 means I'm going to the left by 2. So my original starting position was there, but now it's going to be here, right? And then up by 2. So 1, 2, 1, 2. Here's my new starting position. Now, when you think about the 1 over x graph originally, I like to think about it in terms of the asymptotes. See, this is the asymptote right here at the center and right here at the center, right? And what happens if you go up 1, down 1 from either side, up 1, right 1, you have your first point, you go left 1, down 1, you have your second point, and then you have the graph approaching the asymptotes after that, right? So now, my new graph is going to look similar. So we're going to have these new asymptotes. That was kind of thick, yeah. Let me try this color. So here's my new starting position, right here. And now that means the asymptotes are right along that guy, straight down, and straight across from where he was. So right at 2, 2, right? 2, 2. Okay, now let's graph the thing. So from my starting position, I should go 1 up and 1 to the right normally, right? This would be my normal function. And then like this, 1 left, down 1, like this, right? That would be a normal new version of that. But I also have this negative. So negative means instead of being on the top here, that piece is going to end up on the bottom over there. So instead of going out right 1, up 1, I'm going to go right 1, down 1, and give me this portion here. And instead of going left 1, down 1, I'm going to go left 1, up 1, like this. And then I approach those two asymptotes like that. So that's the red part is the end result, the end resulting graph. Now let's clean up things. Let's get rid of the other original graph. And let's get rid of our asymptotes that we just drew. So we can just kind of see it more cleanly. Yeah, so this is the new graph. That dot is not an actual point of the graph. This is just to tell me where the center is. So I'm not actually graphing that piece. Take that off. Okay, that's basically it. Now, if you're ever confused though, and this one's a little more confusing, then you can always just resort to a table. But again, when you make a table, normally, you know, it's the original 1 over x is 0, 0. So y is equal to negative 1 over x plus 2 plus 2. I recommend starting at the new equivalent spot. Instead of 0, start at negative 2. If I plug in negative 2, I'm undefined, right? and then go out to the left and right from there. Negative 1 to the left would be -3, 1 to the right would be -1. So I plug in -1. I'm going to be in the bottom. -1 plus 2 is +1. -1 over that is going to be -1. Oh, I'm sorry. I'm sorry. Let me do -3 first. If I plug in -3, it's going to be -3 plus 2 is -1. -1 over -1 is +1. Plus 2 is going to be +3. Does that match up here? So this point is -2, -2. -3, +3 would be right here. So that is correct. Yeah, there's 3, -3. And then -1, if I plug in -1 here, that's going to be +1. -1 over +1 is -1. Plus 2, -1 plus 2 is +1. +1. So a -1, +1, that's right there. Yeah, matches. And then from there, you would approach the asymptotes. You can plug in more points if you want to see that, but that's the picture. Okay. One of the harder ones, yeah. Those 1 over something questions are a little hard. Okay, so that takes care of that one. I'm going to just restart the whole graph because this thing is getting out of hand. Oops. Didn't mean to delete that as well. Delete this part. And then the rest I'll take care of with the eraser. Okay. So start a new graph. Okay, this guy, looking at what's the base function. I have a fraction. I've got something with an x squared in the bottom. The base function is 1 over x squared. Another one of our old friends. This one, remember, it's got an asymptote right down the center too. And normally you have the point 1, 1. You get the point -1, but because it's squared, +1. And as x gets big, you get closer and closer to 0. So it's similar to 1 over x, except it's both on the top side. Like this. This is the basic look. And you push this way, like this. Yeah. I was supposed to pass this line, but it's hard to draw well when you're not good at drawing on an iPad, especially. Okay. Anyways, so that's the general look. That's the original function, right? Okay, so what's changed here? So what's changed here? You see this negative here on the top? When you have a fraction, just a small reminder, negative a over b. If the negative's on the... Let me just take a particular example. -1/2. -1 over 2, the same as -1 over 2, or same as 1 over -2. They're all the same. They're all the same things. So that means when I look at this example here, even though -1 is the top, you can think of that just as being a negative of the overall thing. Why am I saying this? Well, that means because you have really f of x, I'm graphing -1 over x minus 3 squared and then minus 2. So what's happening here? I've got to shift 3 to the right, 2 down, and then I have a reflection. That's it. That's it. Easy, 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 easy. So let's start by plotting the new center point. So the original center point of my graph, I think of it as being the origin right there. My new origin is going to be at +3, -2. So this is my new origin. Okay, let's erase the old asymptote. Okay, where's my new asymptote then? New asymptote should be right in line with this guy, right? So straight up from there. Okay, and then also, by the way, straight across, right? So that's at -2. Okay, so now, normally, originally, you would have been 1 up on both sides. You have this kind of shape, right? Passing through those. But this one is a negative, so it's going to be just on the bottom side. So -1 from the original origin. And then the line should approach both asymptotes like this. Approach the asymptote like that. Yeah. Oh man, I'm sorry guys. I just realized I forgot to do the domain and ranges. I've been forgetting to do the domains and ranges. So I'm sorry. Let me do that right now. This one, the original domain was everything except for 0, right? But this time it's everything except for, what is this point? It's at 3. X is 3. So it's negative infinity all the way up until negative 3. Union with negative 3 all the way to infinity. Okay, what about the range? Range, the lowest you could get is right at, this is a negative 2, but you never quite hit negative 2. So negative 2 with parentheses. And then from negative 2, you can go down forever, right? So actually I have this backwards. It should be negative infinity up until negative 2. You can get anything below, but you can't go higher than that. So that's it. That's the main range. And shucks, I forgot the domain and range for the last questions. And I don't even remember which ones I skipped. So you're gonna have to just figure out those ones on your own. But you can kind of tell just looking at the graph, right? Like it's very similar to what we just did just now. So that was number 19. Okay, great. Just one more left. One more. Okay, we've got a step function here. Step function. Okay, so let's remind ourselves what the original step function looks like. So it's also called the greatest integer function, which means if I input an integer, I get that integer back, right? So that's how we start. I always start graphing just those single integers. This is the original, yeah? And then, so original is going to be in black here. And then remember, it's the greatest thing that's less than. So if I input something that's bigger than 0, it's going to still input 0. So that means it looks something like this until I get to that point, right? So it looks something like this. This is not exactly accurate there. That's a little better. Okay, so that's the step function, the original one. What's happening to this one? Well, you get this -1. That means it's shifted to the right by 1. You got a +3 shifted up by 3. So let's take this original shape, right? It's gonna go 1 to the right and up 3. 1, 2, 3. So it's gonna start over here. This starting position moves to there. Okay, and then normally it would have this kind of shape like this, right? And which it does. So normally it'd be something like that, yeah? Next spot would be over here, right? Except this time I have a 2. So what does that 2 do? Okay, so normally the next spot that you'd have the integer function would be right here. Right 1, up 1, right? But this time it should be right 1 and up 2. So your graph should go, instead of a jump of 1, it should be a jump of 2. So a step, it's like you're having stairs, right? But you know how sometimes you have stairs that are like extra tall, like I don't know, some stadium or something, like extra tall stairs, something like that. And then normally from this original spot, if I went 2 to the right, I would go up 2, but now it should be double that, so it should go up 4. So 1, 2, 3, 4. That means this one should be right here. It just widens all the stairs out. So 1 to the left, it should be now here, right? And like this. This one's gonna actually coincide. And then this new one would be right here, like that. And then 2 down, like this. So those are the new stairs. It's just like steep. If you look at it, it looks steeper than the original, right? Okay, so now this is little tricky domain and range. Domain, what are the possible values I could input? Well, I can actually input anything. and get something out, right? I could input a -1 or a -0.5. -1's here, 0.5 here. I could put in 0.0 and I spit out a 1, for instance. So that's fine. What about the range? Range is a bunch of single numbers. And looking at it, this is -1, -2, -3, -4, -5. So looking at, I have a -5, I've got -3, -1, and then here's +1, +3, +5, +7. So I've got all the odd numbers basically. So the range is a set of numbers that are odd. So -5, -3, -1, 1, 3, 5. I don't get 0. And ... both sides like that. So that's it. Okay, whew. Done, guys, done. And sorry again about the missing domains. If you're stuck, I can always re-record a separate video. So let me know if you're stuck on any of those, finding the domains and ranges. But otherwise, good luck with the homework. Let me know if you get stuck with that as well. I can always send you guys some hints via email or make a short tutorial videos if you're really stuck on one. I've done that for a few students already. So just let me know. Okay, guys, have a good day.